Metalloids are elements that have properties that are intermediate between those of metals and non-metals. They are located along the staircase line that separates the metals and non-metals on the periodic table. Metalloids typically have properties that make them useful in various applications, such as semiconductors in electronics, alloys in metalworking, and catalysts in chemical reactions. There are 6 metalloids on the periodic table: boron, B, silicon, C, germanium, G, arsenic, As, antimony, Sb, and tellurium, T. These elements have both metallic and non-metallic properties, such as being semiconductors, that is, they can conduct electricity under certain conditions, and having varying degrees of luster, malleability, and ductility. Noble gases are a group of elements that are known for their chemical stability and unreactivity. They are located in the far right column of the periodic table, also known as Group 18 or the noble gas group. The noble gases include helium, He, neon, Ni, argon, Ar, krypton, Kr, xenon, X, and radon, Rn. Because the outermost electron shell of noble gases is completely filled, these elements are generally unreactive and do not readily form chemical bonds with other elements. This makes them useful for various applications, such as providing a stable and non-reactive environment for certain types of experiments, as well as in lighting and display technologies. Helium, for example, is used in balloons, blimps, and airships due to its low density, while neon is commonly used in signs and lighting because of its bright, distinctive color. The discovery and study of metalloids and noble gases have played an important role in the development of modern chemistry and materials science. The first metalloid to be identified was boron, which was isolated in 1808 by the French chemist Joseph-Louis Gay-Lussac and the British chemist Sir Humphrey Davy. Silicon and germanium were discovered in the mid-19th century, and were later found to have semiconducting properties, leading to their use in electronic devices. The metalloid arsenic has a long history of use in medicine, as well as in agriculture and industry. However, it is also a toxic substance that can cause serious health problems, and its use is now strictly regulated. The noble gases were first discovered in the late 19th and early 20th centuries, largely through the use of spectroscopy, a technique that analyzes the interaction of light with matter. The Scottish chemist Sir William Ramsay and the English chemist Lord Rayleigh were awarded the Nobel Prize in Chemistry in 1904 for their discovery of the noble gases. The unreactive nature of noble gases was initially seen as a curiosity, but later became useful in a range of applications. For example, helium was used to cool the superconducting magnets in the Large Hadron Collider, while xenon is used in medical imaging. Today, metalloids and noble gases continue to be studied for their unique properties and potential applications in areas such as electronics, energy storage, and environmental remediation. Here are some general characteristics of metalloids and noble gases. Metalloids have properties that are intermediate between those of metals and non-metals, can be shiny or dull, and may conduct electricity under certain conditions, tend to be brittle and hard, but can also be relatively soft and malleable, are often used in semiconductors, alloys, and catalysts in chemical reactions. Some metalloids, such as arsenic, are toxic and require careful handling. Noble gases have completely filled outermost electron shells, making them chemically unreactive and stable. Are generally colorless, odorless, and tasteless. Have low boiling points and are gases at room temperature. Are used in lighting, display technologies, and medical imaging. Can be used to provide a stable and non-reactive environment for certain types of experiments. It's important to note that these are general characteristics and that individual metalloids and noble gases can have unique properties and uses. Properties of metalloids and noble gases. Metalloids generally have intermediate levels of metallic and non-metallic properties, can exhibit varying degrees of luster, malleability, ductility, and conductivity depending on the specific element and conditions. Are semiconductors, meaning they can conduct electricity under certain conditions but not as efficiently as metals. Have relatively high melting and boiling points compared to non-metals. Can form covalent or ionic bonds with other elements. Are often used in electronic devices, such as computer chips, as well as in ceramics, alloys, and other materials. Noble gases have filled valence electron shells, making them chemically stable and unreactive. Have very low reactivity with other elements, except under extreme conditions. Have low boiling points and are all gases at room temperature. Are non-toxic and non-flammable. Are used in lighting, such as neon signs and fluorescent lamps, as well as in medical imaging and nuclear reactors. Are sometimes used as a non-reactive gas to fill incandescent light bulbs and other devices where a stable environment is required. Again, it's important to remember that individual metalloids and noble gases can have unique properties and uses beyond these general characteristics. Classification of metalloids and semiconductors. Both metalloids and noble gases are classified and placed in the periodic table based on their electronic configurations and chemical properties. Metalloids are located on the diagonal staircase line that separates the metals and nonmetals in the periodic table. This line is known as the zigzag line or the stair-step line. The metalloids include boron, B, silicon, C, germanium, G, arsenic, As, antimony, Sb, and tellurium, T. These elements have electronic configurations that are intermediate between those of metals and nonmetals, and they exhibit a combination of metallic and nonmetallic properties. Noble gases are located in the far right column of the periodic table, in group 18 or 8a. This group is also known as the noble gas group or the inert gas group. The noble gases include helium, He, neon, Ni, argon, Ar, krypton, Kr, xenon, X, and radon, Rn. These elements have completely filled valence electron shells, making them chemically stable and unreactive. The placement of metalloids and noble gases in the periodic table reflects their unique electronic configurations and chemical properties, and helps to organize and understand the behavior of these elements in chemical reactions and materials science. Some common uses of metalloids and noble gases. Metalloids. Silicon is a key component of electronic devices, such as computer chips and solar cells. Boron is used in the production of borosilicate glass, which has a low coefficient of thermal expansion and is used in cooking and laboratory equipment. Arsenic and antimony are used as flame retardants and in the production of semiconductors and alloys. Tellurium is used in the production of solar cells, thermoelectric devices, and alloys. Noble gases. Helium is used in balloons, blimps, and airships because it is non-flammable and lighter than air. Neon is used in lighting, such as neon signs, and in advertising displays. Argon is used in welding, metal fabrication, and other industrial processes to provide a non-reactive atmosphere. Krypton and xenon are used in lighting and display technologies, such as high-intensity discharge lamps and plasma televisions. Radon is used in cancer therapy and in nuclear reactors. It's important to note that individual metalloids and noble gases can have unique properties and uses beyond these common applications. In addition, the properties of these elements make them useful in a wide range of fields, including materials science, chemistry, electronics, and medicine.